Today we're going to talk about API fuzzing in the SSDLC, problems and possible solutions. So let's continue. So the plan is I'm going to first to tell about us, the presenters, then talk about what do we do at our job. I'll explain why we're talking we instead of an I. Then what is API fuzzing? What are the cases that we came up with when we're trying to implement API fuzzing in our company? The solutions we came up with. Then some honorable mentions, something that's worth mentioning, but we decided not to put it as a separate case, but may come up as a problem during implementation, during fuzzing, and just some summary and the future for API security. So about myself, my name is Arseniy Sitnikov. I'm an application security engineer, and I'm leading currently in dynamic testing, majorly in API fuzzing, so I'm testing APIs for security. So basically, a lot of different companies, a lot of different tools, how to do it. I regularly play CTF, just, crypto, Ascent, WAP security. And I love to do R&D, in security and vulnerabilities, and just security awareness. I write a lot of articles, I do some talks, I do, host CTFs. I'm currently getting my master's in cybersecurity, and I'm kind of a traveler, a geography nerd. I love traveling, I love learning about new countries. So the talk was supposed to give with me my product owner, the application security product owner, Vitaliy Panasenko. He is the chief product owner of application security in the bank that we work for. So he done a lot of things he carries for all the application security practices. And for example, he implemented security quality gates, and just an amazing thing for quality gates. Also a master in cybersecurity, snowboards, also travels. You probably already noticed that he's not here, as you can see. And that's the one reason he got denied of a visa just 2 days prior to this presentation. And when you're looking at this and trying to understand what kind of Eastern European country you're from, I wouldn't tell you because it's not an NDA. You can probably look it up on my GitHub or LinkedIn, but I'll just go on from it. So where do we work and whom do we work for? Once again, not a secret, but let's put it as the bank. It's one of the largest banks in Europe, more than 100 million clients, $19 billion profit from, just the bank every year. And it's not just the bank, it's the number of companies, a family company, an ecosystem with food tech, with deliveries, with e-commerce, with lawyer companies, with animation studios, with robotics, with a separate, GPT agents. It has its own. And so the apps are vary from mobile apps to web apps, from, operation system for ATMs, for example, AI models. And for the whole, all these products, all these apps, they require security. They require to be tested. The bank solely has more than 5,000 teams, which code every day. And the time to market is 7 days from the idea of a project of an app to the release version, it comes to an average 7 days. And so as an application security team, we provide the tools needed to secure all this. So we don't go to a vendor to ask for an SPM, for a full process. We develop everything our own. It's either it could be vendor tools or either it could be our own developed tools. But we implement them, we carry them, we support them, we improve them if needed. So about our team quickly. So there are some numbers of scans, so you would understand how much are there scans for SaaS and SCA up to 10,000 scans a day. That's quite a lot. We have a lot of engines which scan every day, and everything it does in our environment, so nothing goes outside of the bank. And surprisingly, our team is quite low for this amount, so 15 people with mostly being application security engineers, so we just the ones who think of it, who support it, improve and write rules, etc. We have ops that are supported. We have DevSecOps who do our pipeline, develop the tools, analysts, delivery lead, and CPO. And besides, we have a community of 3,000 people who support us, give us ideas, just developers from the bank. Finally, that's kind of all that we do. Let's talk about API fuzzing and what is it, why is it? I think about a year and a half ago, 2 years ago, the leader of our department came to me and told us that we need API fuzzing because we need to test APIs. I've researched it, I've did my a study and found that API fuzzing is a practice for dynamic security practice for testing APIs by sending malicious, misconfigured, I don't know, wrong typed, wrong, I don't know, wrongly formatted data to an endpoint, accepting, sorry, I don't know, some, I don't know, vulnerable behavior, expecting, sorry, some overflows, expecting some, I don't know, unusual behavior from the app. That's basically what API fuzzing is, and just, once again, it's simple practice, usually done by, I don't know, just sending some weird data, some payloads to the endpoint and seeing if it works differently than it should. But at the same time, it's really bad in the world because, once again, nobody tests APIs because usually they think that something as, for example, if they have back-to-back communication, I don't know, microservices they talk to using APIs, then they think that there is a need to test it. OK, there's E wrong. We had statistics that was part of it was made by us, part of it we found online. I think it was like 2023, that 94% of the companies don't really know what to do in case of API vulnerabilities and have encountered them, in fact. And only 11% know them. And so vulnerabilities are vary from just vulnerabilities like SQL injections. I think, yeah, it's OK. So it's vulnerabilities, authentication problems, sensitive data, less penetration, denial of service, and that's OK, fraud. And so there are a lot of cases, and again, they vary very much so. But at the same time, nobody knows what to do. So that's when we decided that, OK, this needs an implementation. Can you do back? I think I missed it. Oh, yeah, thanks. So because nobody really secures APIs, they do unit tests. Basically, in the company, they use, I don't know, Postman scenarios where they have something saved, and they just check if this scenario works. They can, OK, go to a pen tester to a rat team and ask for audit of their code. They can go to a bug bounty hunter, which, once again, kind of works, but it's already, the code has to be in production for it to work. So it's like really shift-right practice. And they can do DAST, but at the same time, it's the same dynamic testing. It still needs a lot of customization for the particular project, and it still requires time. So we thought that we're smarter than everybody. OK, we'll do the project. We'll do API fuzzing. We'll do it easily. It's the simple practice. It doesn't require a lot of things. It's really doesn't have a lot of, I don't know, it doesn't need a lot of power. It doesn't need a lot of memory consumption, a little of usage that we can just implement it. That's easy. So we found a lot of open source instruments like CATS, FUF, WFuzz, API Fuzzer, Wrestler, Microsoft Wrestler. That can be downloaded, that can be used, and a lot of times they're actually used for pen testing or bug bounty hunting, sorry. And they're actually quite good with this goal. And we wanted to be able to parse, I don't know, open API configurations or schemas. We want to have mutations for it to have, I don't know, be better. And mutations are when you send data and each time it changes depending on the output. We want to have multi-threading, so it wouldn't take a lot of time. So it will take, I don't know, 10,000 requests would take about an hour. And we want CV dictionaries for the goal that a user would understand what is the output and why, why is the vulnerability. To be honest, neither of the tools have all these features. And so some of them were impossible to implement in the company, in the bank, because, for example, I know Wrestler, which is quite amazing, it's one of the best, I think, API fuzzers, is built, I think, using F#. And as for me, at the time being, I didn't know how to build it in F#, and the bank didn't know, and it didn't support it. And some, for example, use Mongo, and Mongo is also not advised to use because it has a lot of vulnerabilities, for example. So we decided to use the simplest of them all, WFuzz. It's a Python-based fuzzer. It's really simple CLI tool, which works basically by taking a payload dictionary, by taking an endpoint, telling it where, OK, you need to fuzz this parameter in the header, in the body, in the path, in the query. Give us some authentication data, maybe, I don't know, a token, maybe just basic oath. And it works. It works fine. It gives you the output. It gives you the length of the results. It gives you, I know, the code of the output. It's quite quick. I think it's have It's done using multi-threading, I think, Python. It's quite outdated, being like last commit being in 2020, but still it works. There's no problem with it. It can be built under, I think, Python 3.9. But we at some point understood that it's good for basic functionality that I just told you, but we can't make any more, and we can't do a lot of things around it. So we can't just make, I don't know, some modules for it. We can't just customize the requests because they're already done. We could customize the library, but still it seemed really unreasonable. So we decided to just block it. I think it was 2 months of developing. We decided to throw it in the trash and decided to build a new app, build a new tool, better and faster, stronger. So we first put on the requirements. What are we wanting to build? What do we want the tool to have? So once again, we support the tools for the clients, and the client being the developers of the bank. And they are quite lazy because they have nothing. They want nothing to do with security because they think we're bad. They think that we're slow down their processes. We block their, I don't know, log4j, which they quite love. And they don't want to figure out what is API fuzzing. They usually say fusing, fizzing. I think I heard fezzer. I don't know. So it's really complicated. They don't want to do anything with it. So they want something that is quite simple. You give it, I don't know, minimum information about your stand, about your server. You add it with one line in your CI/CD, in your Jenkins, and that's it. So here are the guidelines. We want to keep it as simple as possible. We want to minimize how does it work and what is inputs and how to implement it in the CI/CD. We want to maximize the number of apps that work in the bank, because otherwise we're just not solving everything, because we implementing a tool so that it covers the whole bank. Once again, 5,000 teams. Okay, no, not everybody have APIs, but we want to cover everybody that have APIs. But at the same time, we want not to lose in the accuracy, because once again, either way, we can just send requests to every server, and that'll be fuzzing. We want fuzz only test servers due to the reason we don't want to break anything that is production servers. And we want to work with authorization because still there is authorization that we need. That's kind of it. It's like minimum, and that's as good as we can get. So if we're talking about CI/CD integration, that actually could be done really quite easily. It could be in the CI stage of CI/CD. Just when you have your code, you committed your code, then you're going to have built, somewhere is here SAS, somewhere here is SCA. You have a distributor of your code. You've built it. You have a test server where you put it, your distributive. At this point already, you can fuzz, because that's the only thing you need. You'll need source code, but I'll talk about it just in a sec. But that can be done. And once again, that can be done in really 2 lines of code. I'll show it, I think, later. So what is the minimum fuzzer? I don't know, how should it look like? Well, like this, like this light blue tower. So it's a simple solution. We have a worker. It's some app that is a container, in Kubernetes, and just container management system so that it doesn't break. It has its own database for storing the payloads and storing some info about the scans. That's received a scan with this such ID. It should have an input of a URL of the the test server, and it should go to the test server, send requests. That's quite it. That's actually quite easy. It's okay. This kind of works, and this is how most of the fuzzers that are existing work. They have like this solution in containers, but the main idea behind them is such. But once again, we work in a bank with a lot of teams with more than, several hundred, several thousand scans a day. How would we scale it up? Because we don't have one instance, and even if there are several instances, they could be, overwhelmed. There could be a long queue. How would you put it? There should be a manager before it that inputs all the requests, send them to a queue, Rabbit queue, a Kafka, and then it's distributed between the workers. This way, first of all, this manager works as a proxy server. It works as an API. It works as a validator for the input. So that, for example, if URL is unreachable, then the worker wouldn't spend time trying to fuzz it. We'll just cancel the request. And it'll probably implement everything we need, and we can duplicate the workers, because once again, it's a container management system, just several pods. Probably like a 10 would cover all the system, because we don't need many more than that. But okay, we scanned it, but where would we put the scan? Probably we could do it in the database, but we already have, just store it. But the problem is that scans can be really big, because once again, for example, if we fuzz, there are several 100,000 requests. If we store each one of them, even just the request, not any info, it's several hundred lines of code. And still, it could be clogged up really quick. So we need a separate file storage, and like S3, for storing the outputs. And then we just have some do management system. When the manager takes in the ID of the request, then it's by the ID, it finds the scan in the S3, and so on and so forth. But OK, it kind of works by this way. OK, we don't have a big queue. We don't have the file system overwhelmed. We can store the storages and the reports, and we can just delete them, I don't know, at some time after, I don't know, a couple of weeks after they were sent. OK, we kind of built a good tool, but what are we fuzzing? Until this point, we have received only URLs for the request, and that's it. We have nothing else to scan. And maybe if somebody was, I don't know, at Red Team API workshop today, we already looked, I don't know, about fuzzing, about finding endpoints. But still, it's a little bit complicated, and it's not always easy to find endpoints. So what are we fuzzing? We can't just fuzz the URL. We can't just go, I don't know, with the spider, find the endpoints. It's not a DAS tool. So we need something to work with. And that would be an API schema, and just an API and endpoints. So that's API fuzzing. That could be really explained by, I don't know, REST API, like technology, SOAP, gRPC, GraphQL. We just need any instrument that can describe us the endpoint that we want to fuzz. But that raises a problem that we need somehow to understand them. We need to create our own context. So at the worker, we will need to know how to parse particular endpoints. I don't know, it's open API. It should be, once again, gRPC, GraphQL. And we should get the information that we need. So it's either, I don't know, the path, the method, the parameters, the type of parameters, the maximum length of parameters, the example data of parameters. We need to understand it all so that we would know how to make further a request needed to fuzz such API, such endpoint. Then, at this point, probably it's all solved because we have an API schema. It's parsed. It goes. We parse it. We have APIs. We have payloads. Then the payloads are added to the API. We fuzz. I haven't mentioned one problem with API schemas. Are there any API schemas? Sadly, no. Nobody has API schemas because, surprisingly, nobody wants them. Nobody needs them. Because usually they have, I don't know, somewhere a text of written, I don't know, on a page of what the API is like. They have either, I don't know, somebody who worked in a company for 50 years who knows their endpoint and every method, or more realistic scenarios that they have, I don't know, somewhere like, I don't know, on corporate wiki the information, but it's stored as an, I don't know, table. They may have, I don't know, API schema, but it's outdated because, once again, time to market is 7 days, so the documentation is updated really much slower than the code does. And there could be a lot of legacy systems because, once again, it's a bank. We work there for, I think, like some systems have been developed for more than 20 years. And so they're really, I don't know, in Java 7, or at least 11, I don't know. They using known frameworks. And they were written by somebody who's already, I don't know, 9 years old, still working, but doesn't know anything. So we need somehow to understand what we need to fuzz and how to get these API schemas. And we can do so by scanning the source code. Because once again, we already have it for SAST. Why wouldn't we use it for API fuzzing? Basically, we find potential API descriptions. So we find sections of the code that seems like they describe APIs. That could be done using regex. That could be done using by some rules, I don't know, from known frameworks. But basically, if you see word that sounds like get or post, you see slash, probably that's a description of an API. Or, OK, there are more, of course, rules, but it's the simpler version is that. Then there are a lot of known frameworks. I know there is Spring Boot. There's, if Python, we're talking about Fast API, Django, Flask, which all have a special system of describing API. So we can just, I don't know, build an abstract syntax tree, parse it, and then, OK, we have the API configuration with all the parameters, with all the restrictions, everything we need. We can do just, I think, parsing without an AST, but that seems like more fun. And sadly, I'm saying sadly because it seems like mainstream, but still, if we don't know the framework, we can use generative LLM, because surprisingly, it does the job well of creating an API configuration. Just to prevent any questions, we don't use, I don't know, a GPT wrapper, because once again, it's forbidden. We have our own generative LLM, corporate one, so the code doesn't leave the company at any point, but still, it generates, and once again, it's really good for some legacy projects that are like 15 years old, that don't have any, use any automated wave to generate API configurations, but still it works. OK, that's not how it is. And so this way of generating API configurations really solves a lot of problems, because nowadays there's a huge trend of not knowing what your API endpoints are, and a lot of companies did research that I think most of the vulnerabilities that come with API vulnerabilities is because they're unknown endpoints. I talked about the reasons why it should be like this, but basically it could be a debug endpoint that you haven't deleted, or once again, some part of the code you never touched and it's just there, but it's not in the Swagger, so you just don't see it. And also it solves the problem, as I told you before, the developers don't trust us and don't like us. We don't like them as well. So we don't trust them that with the code, with the API configuration that they send us. So they could send us an API configuration with one endpoint, I don't know, with a health check, just path, we'll scan it, everything's OK, they'll pass. But at the same time, they'll have, I don't know, 200 other endpoints that we need to scan. So we solve this problem, everything stays up to date, and we can do this way incremental scanning when, for example, you've written a new part of the code, a new section, a new functionality, and we don't need to scan the whole app, because there could be, I don't know, more than 100, more than 200 different endpoints. We can just scan several few which were added. Let's talk about authorization. That's actually quite simple. And the first thing I want to tell you that we won't be using, I don't know, any session tokens, any, I don't know, cookies. That's because it's mostly done for front-end to back-end communication. And that could be covered by Dast. So, and we don't want to already a simple practice as API fuzzing has grown into like this huge segment, and we don't want to grow it with creating separate methods for, I don't know, form-based authentication, time-based authentication, cookie-based authentication, GVT tokens. We need to, and besides making our code bigger and the app just more uncomfortable to work with, we make it less, more vulnerable, because once again, developers could come to us, send us, I don't know, malicious ways of authentication, and I don't know, we'll have an SSRF because we don't have a way to check it. So we work with either MTLS, mutual TLS, which is popular in a lot of inner communication between microservices. It's quite simple. We could just add certificate to our, I don't know, to our ingress, for example. And we can both work with static API tokens. So that's basically when you pass a token to we have a token as an input, and we just pass it with that request. It actually don't have to be static. It could be dynamic, but we fully depend on the developing team that gives us the information. If the token gets outdated at some point, that's their problem. We'll just get, I don't know, 403, and that's it. Finally, now no lies. We've done everything architecturally wise. We won't add anything. Now we need to understand what are we fuzzing and how we would get the results. What are we sending? So there are payloads, and payloads are quite simple. It's just regular web vulnerabilities. So like any kind of ejections, path traversals, any kind of broken access control, just anything you can think of, you can find a payload for it, send it. If it breaks, it breaks. We'll talk about in a couple of minutes how would we find such vulnerability. But also is an interesting one. There are IDORs, and IDORs are really important because no other practice can find them, because it's hard for SAS, it's impossible for SCA. It's kind of possible for DAST, but DAST usually doesn't support a lot of users. And so here we could have several users. Fuzzing, we can have several tokens. And we could check for different accesses, different roles, different role models for the objects. Why I have a question mark there is because it can't be done out of the box. Because if you have a user, okay, 2 users, if you have objects, we need to know this object's IDs. It could be simple like as 1, 2, 3. Okay, then we'll probably have it as default. But if you're using UUID or any other object identification, we probably need somehow to get it from you, from a developer, to check if we have access to it. Then we have something called modules. And modules is something that makes fuzzing not that dumb. Because besides it, we just send payloads, we get reports, responses, and we try to get it in a report somehow to get it together, group it up, whatever reason. But modules are more smarter and something that you can add to a fuzzer with a special logic behind it. So for example, that it doesn't just send a request, get it back, that's it. So if we're talking about DOS, then our service is interesting because we don't really need to know what are the responses because we don't really care. We want something that breaks the app. Maybe the app, maybe the Nginx, maybe the pod, I don't know. We don't really care. We just need something, big, something long, something many requests. And we're looking just for errors, at any point, just to receive 500, 501, 500, 502, just 500 family responses. There are role testing. That's kind of the same as I talked about already IDORs, but we can do it in a separate model, and by checking, not only for IDORs, for object roles, or we can talk for authentication, like BOLA. We can talk about different roles which have the access, etc. But this needs some specification of which role has access to which page, to which object, to which method. Race condition is quite actually interesting because it's, for example, at the bank, it's really popular in many banking apps. I don't know how popular it is, but I know that at every interview I get asked about race condition and transferring funds between different accounts. So that's basically you have the same endpoint. You're sending 2 requests, either at the same time, either a couple of minutes just between them, and you either expect the same result, either you expect different results where it should be the same. So just some specification, you're looking for this. Finally, there's an endpoint searcher, which is, once again, we can go back to the reasons why it's important to know all the API endpoints that are on the app. But basically, you can just have like a recursive algorithm for just going really deep for finding any endpoints by using most popular names like API, create, user, delete, etc. So adds just the names. If it gets not 404, it can go deeper. And so once again, it's important for either finding disclosed information that could be stored somewhere, just in the file system. Either once again for finding endpoints that weren't mentioned in the API configuration. And just an example here is SSRF. I've mentioned it because it's one of the most, from my opinion, not understood vulnerabilities by the developers, because somehow it's hard for them to understand, and server-side request forgery doesn't make any sense as a term. Therefore, they don't really somehow protect their apps against it, because it says, okay, we have a whitelist, okay, we have a blacklist, and then you try to explain to them, okay, whitelist don't work. They have how they don't work. You explain to them, okay, there are encodings, there are different ways, there are different types of way how you could input an URL. There are user that you could add to URL and which will get interpreted wrongly, but it still doesn't make sense. Therefore, we have a special module for SSRF, which each injected URL is address of our app, which if it gets a request, we understand that there was a successful SSRF attack. So now going back to defects, and that's when we just send regular payloads. So we have an endpoint, we have a parameter, I don't know, let's say in a query or in a path. We've entered some payload, an SQL injection, some report and a response with, okay, let's say 200, so it's okay, with some response, with some text, and that's it, all that we know. How would we automatically understand that this request is vulnerable or not? Because, once again, the goal is not to triage all the defects, because there could be several hundreds of them. We need to minimize them for the developers to just work around them. So that's, I'll explain this one in a sec because it looks a little complicated. So there are a couple of rules that are pretty simple. So first one is ignoring all 400s and 404. That's just because 400 is probably you messed something in the request. That means that you, I don't know, sent in a string where it should be an integer. Kind of a mistake of a tool, but probably you don't really need to see it. And 404 probably means something that you've mistyped. I don't know, it's a URL for getting an access to a file, and you haven't got access to it. That's pretty much fine. For 500, we need to understand that if it's a server mistake or if it's a denial of service, because if it's just a server internal error, then we should probably output it as a vulnerability. But if the server is down, maybe it's down because we caused it, maybe not, then we should probably wait with the request, because we don't need to fuzz a down server. Then we can scan for secrets or any personal data in the responses by using a secret scanning tool, I don't know, like TruffleHog, for example. Just finding it could be personal information. Once again, it could be some I don't know, passwords, etc. We just, once again, a basic popular tool to use AI for triage. We actually don't use it, but it's one of the tools that can be used. And finally, explaining the plot on the right, I call it mapping to 100 by response time and size. So what does it mean? So let's say we have an endpoint and we're sending, I don't know, 1,000 SQL injections to this endpoint. And by the logic of an app, most of them will get processed by the same amount of time with the same amount of time consumption, and will give out probably the same output. Once again, it differs from an app to app, but here, for example, I have an example where most of the responses have 125 words, or like 120, I think, and it's 1.4, I think, milliseconds for the response on average. We can grab mean squared error from it, like walk around it, and say that every response that in this rectangle is kind of okay. Okay, there are, of course, a lot of fluctuation because there could be, I don't know, different problems in the network, problems on the server. There could be a lot of different numbers of words, because I know if you ask for 2 Google pages, they would probably have a different amount of words, but still, they probably should have the same. But there could be cases when, I don't know, for example, the time is really low. So that means probably that there's been an error and you've just received an error. Or the time is very long, and that could be, for example, I don't know, time-based SQL injection, so it worked. The same, for example, with the number of words. So there could be a small number of words, and it could be that, okay, it was a 200, but you received just something as, I don't know, an error message in like a JSON. And the same with a lot of words. It could be, I don't know, you dump the whole database as an output, and it gets to the result. Of course, here's like an extreme example, I think, on some test app that doesn't really work, but on the real cases, okay, the rectangle will be bigger, it will be less centralized near the mean, but still it'll look kind of the same, and there'll be values that are out of the rectangle. And once again, you can use probably not a, I just use mean squared error. It could be used 2 mean squared error. It could be used, I don't know, any other fluctuation, the matrix, I don't know, the just mean deviation, something like this. Finally, we've sent all the requests. We've received all the responses. We somehow mapped them. We need to show it to the user. That's how we first done it. And I found it quite amazing. It's quite useful. I understand everything about the report. It looks great. OK, it was a JSON. Of course, we had an UI for developers to see. But it's just a list of vulnerabilities. We have an endpoint. We have the payload that was sent. We know that it was ID. We have the header of the body. We know the method. We know the code. We know the response. Probably that's all that we need. We now can work with it. We even have, once again, the vulnerability and severity for users. We don't actually need it as engineers, application security engineers, but probably users need it. But there was a problem that this way, for example, a user opens a report, sees that there are 300 different vulnerabilities, and he doesn't know what that means, and doesn't know what to start with. And to be honest, doesn't really care. He just closes it, tells it, OK, that's not actual. We don't need it. That's something that's, I don't know, fake. We won't triage it. So we had to change it for the developers. And this way, we changed it so that there is, OK. Yeah. So vulnerable for the developers. So that means that now we don't have vulnerabilities as our object. We have endpoint. For example, here it's user/ID. And that means that we say that you don't have, I don't know, 300 vulnerabilities, you don't have 300 defects, but you have, out of your 25 endpoints, I don't know, 10 of them are orange and 5 of them are red, meaning that they have more vulnerabilities than the other. There's a ranking system, but that doesn't really care. Then we split each endpoint by method, so it could be get post, but usually it's one method per endpoint. And all the information stays the same. Instead, we add the curl, because users really need the curl, because they don't believe us, and they need to check for themselves if the vulnerability is vulnerable. It doesn't usually work this way, because they could add, I don't know, it could be a door, it could be a DOS, that wouldn't work with just one curl. But for any injection, for any, I don't know, just regular vulnerability, one request would work. Now for the honorable mentions. By honorable mentions, I mean something that we came to as a problem, but we decided not to put as a separate case, because it's something that's really specific to big companies or just to, I know, small teams, and doesn't require a separate case. So first of all, it's firewalls, because of course there are inner firewalls that even if we test the test apps, there still are there. And here we had to solve it by not scanning the firewalls. Basically, that means that we expect that every app should be secure as a whole, without any other, I don't know, methods for security. I don't know, without any firewalls, without any, for example, a backend should be secure, even though the only access to it is through a front end that is secure. Because once again, there may be cases when this app migrates to another company, to another, I don't know, section of the company, and that, this way it'll stay vulnerable. So we try to fuzz everything without the firewall, because firewalls really mess it up a lot. There are also custom HTTP codes. It's when, for example, you send a request to a server and it returns you, I don't know, 600. The time on the server differs from the time on the client. And you can't really understand what it means. So this is somehow a way you need to pass through the instrument, the tool, that, OK, there are custom HTTP codes that you need to be counted. Also, I think you talked about it on the workshop about response code in JSON. That means when you have all the responses are 200, it's OK. But in the response in the body, there is, I don't know, there has been an error at the server. There has been, I don't know, this method is not allowed, for example, or something like this. And, or or it has, I don't know, 400, I don't know, just bad request. This actually is, if we're not even talking about API fuzzing, that should be a bad request or a bad practice, because it shouldn't be like this. Teams should return appropriate responses, codes to each request. And this.
Can I have a question on this one?
Yeah, of course.
Because I was working in bank, and
yeah.
exactly, we had like policy. I think it was even like security standard that we
yeah.
are not supposed to return to in the environment, like production environment,
yeah.
we shouldn't be returning code exactly like 404, 403, 402. There was supposed to be one 400 message basically general, so no one can mine the information based on like just like trying to.
Yeah, and this is usually the goal of either reverse proxies or either firewalls that should be doing this. But once again, as a practice, as the best coding practice, each app should return appropriate response, once again, for the reasons of testing, for the reasons of working with an app, so that, for example, when you try to work with logs of, I don't know, the same firewalls, you could understand what will be the vulnerabilities and not just understand that everything is wrong. So once again, a problem of a big company, we have different network areas, which that means that, for example, at the beginning, we could fuzz only about, I think, 35% of the apps in the company, because we didn't have like L3 access to the other ones, because they're all separate. And so we had to put out, first of all, we did it like, once again, several reverse proxies, but then we started adding instances of our fuzzer in every section and just having access to it, just having a port that has an access to our network area. But still, it's a big problem that nobody thinks of. We didn't thought about would be a problem, but it is. And it goes to the second problem of the requests are blocked by the security department, by a blue team, because we're sending several 100,000 requests every hour. That's not something that nobody usually does in a company, in the environment of a company, because there's not something that needs so many requests. So a lot of times we get blocked, but by having a couple of meetups and writing down a couple of explanations, we finally get access that we won't get blocked. So summary, it's quite simple. API fuzzing is actually quite good, surprisingly. But when you're trying to do it and not as a fantastic practice, not as a bug bounty practice, but you try to scale it up to the process of the whole bank of the 5,000 teams, there may come problems that may not come up with, I don't know, any other SAST, SCA, or any other tool, which that just require resources for scaling. But you need something to ignore the business scenarios, because you have no way and no time of inputting them to your system. But at the same time, you need to keep the accuracy that is kept by making the tool better. And so how to grow it? Actually the same. So we can use AI for generating context. What I mean by context is by, I don't know, looking at the app, by looking at the API configuration, AI could tell the request we should make. We can make an integration with SAST. For example, it could be something like yes, so when you fuzz and at the same time you see which part of code is being called, so that way you, I don't know, could look for buffer overflows or any other mistake that could be reason in code. Integration with Dast, that's actually, once again, it could provide endpoints to Dast and vice versa. Dast can provide some information to API fuzzing. And would be cool if we could import user business scenarios. So for example, I don't know, there's a system where you go through, you press a couple of buttons, use a request and first an user ID, then with the user ID you request an object ID, and with the object you go, I don't know, add it to another object, for example. And this requires actually a lot, because from my point of view, okay, it could be written down as I don't know, just number of requests, but once again, we can't receive it from a user, because it'll be vulnerable from if we just receive some sequence of requests from a user, because they can send us, I don't know, once again, it would be possible SSRFs, because once again, we don't trust the users don't trust us. At this perfect point, I'll thank you for the presentation. I'll read some questions if you have them. So here's contact information, mine and Vitaliy, who sadly got stuck at the border. Thank you. Yes?
Is your team aggregating and reporting on the results? If yes, how are you aligning that with any sort of application inventory?
What do you mean by reporting? Reporting it?
Like you would do with like SAS or DAS findings. Like this is aligned with this microservice or endpoint. You know, we are finding this consistently, or like they're remediating this over time.
Okay, so basically, does it work back? Okay, it doesn't work back. So we have, when I talked about our tools, we had ASPM, where we have all the results. And so one of the results is API fuzzing. So we basically tell it got fixed by the same release. So if you're releasing this code, first it tells the SS, then it's SCA. Then for this release, so for this distributor that is built on the testing app, we have, OK, for this version, here are the endpoints that are vulnerable. Yep, thank you. OK, that's probably it. Thank you. Thank you. Yep.